Welcome everybody to another tutorial session from Nairo Research. I'm Srijit here, and in this session, I'm briefing about the applications of DFTB. And in this specific session, I will be focusing on NEB or Natural Elastic Band. We have already given an intro about NEB, so I'm just focusing on one simple tutorial that how we can use this method to identify a chemical reaction in vacuum and also ionic diffusion in a solid. So just now I'm focusing on a chemical reaction. So how to locate a transition state? Let me change this engine to DFTB and the task to NEB. Okay, and now, so NEB methodologies. So in the first example, we will find the minimum energy reaction path and transition state of the following reaction, like a diene and a diene file. Let me import the initial systems from files. So let me go to downloads. I have already downloaded the initial structures. See, this is actually the reaction of our study. I mean the reactants of our study. So let me change to initial systems. So we'll be using DFTB engine with the GFN1 XTB panel. So this actually methodology for the model which we are going to discuss today in this session, and then we will be focusing on what the final system. So this is computationally fast method which is convenient for the purpose of this example, but it is not very accurate in predicting reaction energies. For better accuracy, we should recommend using the DFT engine like ADF or BAND in this suit. So now let me set up the final system. So let me go to edit a new molecule, and then let me add this new molecule here as the final system. Let me import from coordinate from files. So from files, let me go to downloads and NEB final. So this is actually the final system, final structure. So let me rename it as NEB underscore final. And here I need to select, and then I need to check this characterize PS point. So when setting up the NEB calculation, we need to be specify two systems: the initial and final states of the reactions, which I have already shown you. The NEB algorithm will then generate a set of images by interpolating between the initial and final systems. This will be the initial approximation of the reaction path, which we will get optimized during the NEB calculation. So I have already set all those things, and we can usually switch between the drawing area between initial and final system. So this is actually the methodology. So for your kind information, we have already conducted one demo session or a webinar session with the same example using DFTB and ADF. So if you want to verify or if you want to check it, you can visit our LMS platform, which is known as nairo.graphy.com. So there we have briefed with the transition state search of Diels order reaction. So how we can locate Diels order reactions transition state using NEB. So it is very important that in NEB calculation, in order to the order of the atoms in the initial and final system should be the same. If you provide an intermediate system, you should use a convenient or consistent atom ordering of that too. So the order of the atoms should be consistent because the images interpolation algorithm maps the nth atom of the initial system to the nth atom of the final system. So now we will be executing the calculation. So let me save this thing. So we have already created all the inputs. So it's a small small reaction, though it won't take that much time. So let me save it as NEB underscore node one, because I have already executed the calculation in the same server. And now let me go to this and run the calculation. It won't take that much time. So why I have selected this specific example is that to brief you that what are the applications of DFTB and how we can compare the results with ADF and BANT. So I have briefed the same calculations with our own, examples, as I mentioned in the about our LMS platform. You can refer it. So I have done two different webinars with BANT engine and ADF engine and MLP, covering the ionic diffusion, which is useful in battery modeling and diffusion coefficient, and also this how to locate the transition state using NEB. So you can refer this examples. Let me show you the output or the animated output of our calculation. So you can see that how it will form the transition state and that reaction. So we can see that from the graphical representation. See, so around by this point, and so at the left hand side you can see the frame, on which frame it is showing that bond formation, and this is actually on frame number 8 that reaction is complete. Okay, so we will see in the next video with another technical session. Thank you.